All right, in the last video we talked about roughly a general idea of what the project was. It is a rolling sphere that is driven by two pendulums. In this video we're going to talk about the drive system and where we're at with the drive system. So the pendulum is hard mounted to a motor. The motor drives the pendulum forward. This is, by the way, a front view looking straight at, we'll say, this pendulum. This section right here, I'm drawing it in general as a box, but essentially this part of the pendulum is the counterweight. When this counterweight moves forward, which would be out of plane on this, when this counterweight moves forward, my sphere rolls forward. The heavier this is, the more motor I need, but at the same time, the more roll I get to maintain my center of gravity. So when looking at the drive system just as a general, right now we have two motors just because it's made out of Lego Connects or Technics, and so we need the extra power. But a complete analysis is going to need to be done on what motor we need, and also how much batteries we need. The batteries are stored in this container, and this container, we're going to try to maximize the size of this container because you want the pendulum to be heavy. You also want the pendulum to be, we are going to want it to be our battery storage area. So right now it has 3 AA batteries inside of this box. These will, I imagine, be hopefully lithium at one point, but maybe NiCad to start with because it's cheaper and we can mimic RC car setups. So right now we just have the batteries, but this will be battery storage. Our energy lines will come up, supply, all of our power will come up and supply power to our motor. Our motor is connected to a gear, and the gear is connected to essentially another gear, which is connected to this pendulum. So power supplies, our batteries supply power to the motor, motor spins the gear, gear moves the pendulum forward, sphere rolls forward. If I want to actually go forward, both pendulums rotate at the same rate forward the same distance. So if I were to rotate just this pendulum and leave this pendulum stationary, I would go into a turn in this direction. And, you know, same for the other side. So the general idea behind this, and like I said, this is built out of Connects, and I'll make a video showing our current system driving. We have it in at the university right now. It's Professor Gotzi and I have brainstormed and came up with what we have currently, and unless we're working on like personal ideas about the project, we typically just leave it in his office, which is our shop essentially. So that aside, what are we looking at with this drive system? We're looking at maximizing this container size to maximize the weight of my pendulum and maximize the amount of space I have to store my batteries, because this sphere is for hauling, storing, and charging drones. So charging being one of the main purposes that this thing does. The more batteries I have, the better. And this is an area where when I add weight, I add an advantage, which is speed, as long as my motor has been designed properly. So we want to maximize battery storage space. What is our thought process on what that may look like right now? If we had a side profile of this, like this here, our current system kind of looks like that, sort of. We are thinking of maybe something like this. And each one of these little pendulum pods inside of the sphere would, my thoughts are, you know, usually a NiCad RC battery is just a bunch of them connected in a strip with a connector. So if we cracked open this sphere, we could pop open these doors, swap in batteries, and that just made me think of another thing. We should probably have a charging port of some sort, as far as instead of individually pulling out each one of these batteries, I should be able to just plug in here or wherever and charge all of the batteries when they're still installed. So maximizing this would be maximizing this space, which, you know, there's other options, and this is something that is part of this engineering process, is finding out what should we do here. That is our job. What should this pendulum look like? How big should this pendulum be? How many batteries should we put in it? How many batteries can we put in it? The stresses on this pendulum, the stresses on this part of the pendulum. So that's one aspect of the drive system. The other aspect of the drive system is doing an analysis on what size motor we need. What motor with what specs would be best for our application is a major part of this drive. I mean, it's basically the part of this drive system that is the most important. I mean, you even think of drive system, you think of the motor. So the pendulum needs to be the first decision to find out what we're going to need as a motor. And a portion of the motor is this gear train. What gear ratio should we use? This is where we're currently at. The proof that the sphere will move is complete. The drive system we have currently needs tweaking, and we're working on that right now, just to be able to just set it in the university and drive it around. Like, consistently. I said in the very first video, we are skipping teeth and just little minor stuff like that. It's a matter of just building it a little bit better. But as far as engineering goes, what we have right now is a proof. It's not our product. So we have to analyze each one of these little parts to a system individually in order to move forward. So these are big picture items. Each one of these items has many, many, many subcategories of things that need to be analyzed, engineered, thought out, and then built. And that is the focus of this project. The project is an engineering project. So it's not a let's go in the shop and see what we can build. We will still do that for proofs of concepts, but what materials to use, what is best suited for our application, that's where we do our engineering. Then we go get those materials, then we build it for real. So that's where we're currently at with our drive system. Like I said, I'll have a video pretty soon, maybe Tuesday. I could do a video on us actually messing with what we have right now. So the next video will probably be what our thought process is with the hatch design and the plate.